Hi everyone, today I'm going to talk about the backtracking algorithm we're going to use in Project 1. So first, before we get to the 3D method, I'm going to just talk about a 2D method. So in this case, you can kind of consider it as the input with only one color. So I'm using the same format where you have like hashtags for walls, periods for open spaces, we have the asterisk as our starting position, and then the question mark is our target. So if we're going to follow the algorithm in the spec, the first thing we're going to do is we're going to create our backtracking structure, right? That's going to represent all of the states that we can attain inside our map, right? So I have two distinct 2D vectors, right? One contains my map, the other one contains the backtracking information. So the first thing we're going to do is we're going to, again, mark them all as unvisited. That's following this code I have here, right? Where I have a unique value for unreachable, for direction, and then for the starting position. And then we're going to say that our starting position is now reachable by using this code, right? With it's like a null character. Next, we're going to take the starting position out of our reachable collection, right? So I already put it in here. We're going to take it out. So that's 1, 1, and then we're going to add all of its eligible neighbors. So looking at this, we can see that the eligible neighbors are going to be 1, 2, right? Or well, it's going to be 0, 1, right? If we go in order. And then 1, 2. As you can see, right, the one below it and to its left, those are both walls, so they can't be added. When we add them to the reachable collection, what we also need to do is we need to update our backtracking vector to say when we added this state, right, is like a 1-to-1 correspondence. When we added this state, where was it added or why was it added? And that state is going to always be a state that's directly adjacent to it. And so that's why we can just use a left, right, up, down, like ordering. So for this one, we're going to point to the left for 1, 2, and then for 0, 1, we're going to point downwards. Next, we're going to pretend that we're just using the queue mode. And so next, we're going to take the oldest item out, and so that's going to be 0, 1. So that's here, and we're going to look at all of its neighbors and add the ones that are eligible. So from there, we can add 0, 0. And then we can also add 0, 2. Since it's on the border, and since looking at our backtracking information, right, since it's not an X, right, we said X is unreachable. Since 1, 1 is not unreachable, it means it is reachable, and so we're not going to add it back to the reachable collection again, right? We removed it, we're not going to put it back. Again, when we add these ones, we also need to make sure they point to, right, we can call it their parent, which is the state that they were added because of, right? And so these are going to point, again, to 0, 1. We're going to take the next item out of our reachable collection, which is going to be 1, 2, and then we're going to add its eligible neighbors. So that's just going to be 2, 2. Again, 1, 2 is not unreachable, so we're not going to add it again. And then and then same with 0, 2, and then it has a wall at 1, 3. And then this is a starting position, so it's also already reachable. So again, we only add 2, 2 to reachable collection. We're going to then take our next item to be 0, 0. Looking at it's pretty much in the corner, so there's nothing that can be added to its left or above it. And then there's a wall beneath it. And then again, the item 2, it's looking at the backtracking vector. The item to the right is already reachable, so we're not going to add it. And then for 2, 2, again, we need to make sure we add that backtracking information. So again, you're going to add the backtracking information as you add them to the reachable collection. Right? Don't look at it. The point is that you don't want to kind of look forward, you want to look backwards. Our next item is going to be 0, 2. The same thing that happened with 0, 0 is going to happen, where nothing really can be added. And then so we're going to look at 2, 2 again. And then from there we can add 2, 3. That's going to point towards 2, 2. You can take 2, 2 out and then add 2, 3. And then finally, again, 2, 3 is next. Again, only thing that can be added from there is going to be 3, 3. Now you can see that 3, 3 is the goal. Now in this case, we just added it. So we need to again update the backtracking information. And then we can kind of say like one iteration has happened. We're now going to take 3, 3 out. referencing with the map, we can see that 3-3 is the goal, and then that means that we're done. So that actually means that this is the solution, or you call it the end, right? We're now going to do our backtracking. So what we were doing before, that's just the searching part. Once you're done searching and you find a goal, or if at some point we managed to exhaust everything in the reachable collection, right? If there was like a wall here, we would have exhausted everything in the reachable collection before we got to the goal. In this case, we got to the goal, and so that means that there is a solution to get from the start to the goal. And so we're going to now backtrack to figure out what series of paths got us there. Erase this, and then we're going to call this our path. And so you can store your path in a vector or a deck. If you store a vector, you'd probably use like push back to keep adding each one as you navigate back to the start. In which case, you're going to end up with the path essentially being backwards. And then so you could use like a reverse iterator to traverse that, or you can use STD reverse also to just reverse the entire vector. So in this case, again, the path we know, because we saved it earlier, we know that it's going to start with 3-3. And again, remember, this is just like a one-dimensional example, so I'm not considering colors, so I'm just using like row and column numbers. So we're going to start from 3-3, and looking at our backtracking information, we can see that 3-3 is going to point to 2-3. So we're going to now look there, right, we're going to add it to the path, and we're going to say, all right, I'm at 2-3, where does my backtracking say I need to go from 2-3? It says I need to go now to 2-2. Okay, and then from 2-2, where do I need to go? I need to go to 1-2. And then finally from 1-2, points back to the start, that's gonna be 1-1. And you can see we use the unique character for the starting position. That way, once we backtrack to the start, we know that we can't really backtrack anywhere because that's where we started. It's kind of like a null character in a C string. So this is our path. Again, right, if we read in this order, it's backwards. So we need to read in this order if we're gonna print it out. Like for list output mode, it would be printing in this order along with the colors. For map output mode, we can sort of create the map how we described in the spec, removing the buttons and the corresponding walls, and then walk forward and then add the pluses, the percentages, and the asterisks where they're needed. So I hope you're able to follow that. Next, we're going to talk about a 3D example. Now we're going to talk about a 3D backtracking example. So here, again, we have our 2D map, but now we're going to have 3 colors, including the trap color. And so we're going to need a different backtracking 2D vector for each of them, one for each color. And so we kind of can combine them to think of them as a 3D space where our z-axis is like our color, and then our x and y axis are going to be the rows and columns. So again, as you saw in the last example, in 2 dimensions, right, we could backtrack between the 2D planes using just the same from north, east, south, or west. But now we need to add a different backtracking method to go between colors. And so we're going to talk about that in this example. So following the same algorithm, we're going to mark all of the states as unreachable, right? So that's across all 3 grids. And so we're just going to consider it being empty, meaning it's an X and that it's unreachable. And then next we're going to take our starting position, right? So that's 0, 0. And then we're going to mark that as reachable in that it is not an X. We're going to use the same sort of like, again, null terminating character to say that this is a starting position. And then from there, we're going to add the neighbors. We're going to do this in queue mode again. And so from 0, 0, we're going to add 0, 1. And then 1, 0. And then also we need the color, right? Because we're in 3 dimensions now. So the states have 3 parameters. So it's 0, 1, right, trap. And that's 1, 0, trap. Next, we're going to, again, update the backtracking information for each of them. So this is going to point, right, since this is the same color as the state that it was added by, we can say that it points back towards that state. And then from here, we're going to look at what comes next in the queue. So it's going to be 0, 1 in the trap color. From there, looking at our 2D map, we can see that since we're in the trap color, this is considered a wall, so it's not reachable from that state. This is a button, right? And so since it hasn't, right, it's a button in the trap color. So since it hasn't been reached, right, we're going to mark it as reachable. And then finally, again, the starting position was already marked as reachable, so we're not going to add it to reachable collection again. So we're only going to add the button. And so that's going to be 1, 1, A. And so this is kind of one of the nuances in the spec, in that even though A, technically by stepping on A, you're transported to like the A floor, right? We're going to, when we're adding it to the reachable collection, we're not going to consider a button until we take it out, in which case we're then going to add the adjacent A colored tile, right? And so we're first just going to add it. So actually, okay, this is wrong. This should be 1, 1 in the trap color, right? So those are all of the reachable states from 0, 1. Next in the queue comes 1, 0. From 1, 0, as you can see, looking from here, there's nothing adjacent to 1, 0 that is not already visited or is traversable. And then so next we're going to look at 1, 1 in the trap. That is a button. And so because it's a button, we're then going to add 1, 1, same row and column, but now it's a different color, right? And so what this pretty much is saying is that it says that walking on a trap takes 2 steps, right? First is walking on the trap in the color that you were in currently, and then you're going to walk on the trap, on the button in the color that it actually is. And when you're in that color, right, the button isn't really a button anymore. Stepping on the A button on the A floor takes you to the A floor, but you're already there, so it doesn't do anything. So now this is a tricky part. We can't say north, south, east, or west, right? For this now where we're trying to backtrack from, right? This state represents this tile, so we can't say north, east, south, or west. We need to say that the rows and columns are the same, but now it's a different color. So you could use like a relative positioning, like just say like minus or plus, but I think it's simplest if you just say what color it came from. And so in this case, we're going to kind of add a new parameter for like our backtracking code, and we're going to say we got to this state again from the trap color. So we take that out, and now we're going to investigate where can we go from this state. And we can see that now we can actually go back to this tile after we step on the A button, because in the A color, we're now actually talking about this position, right? It's a completely, and so on a separate floor, it's actually not explored. Again, our states have 3 parameters. We have a backtracking information for all the states, but we're not going to like create all the states and enumerate them before we explore them. So from here, we're going to add our adjacent, the visible adjacent states, and so we're going to go in the same order, same floor. So now we're going to point this one down. There's a wall here, and then there's a B wall beneath it, and so we can't traverse that one. So we're just going to add these backtracking information. And so that's going to be, first we added 0, 1 in the A color, and then 1, 0 in the A color. And so again, we used these row and column combinations before, but now it's a different color. Taking the next one out of the queue, right? So that's going to be 0, 1. So we're looking at this position. On the A floor, the A wall is open space, and so we can add that to point back towards, we can now traverse that location. This is the starting position, but now it's, again, a different color. So it's going to also be new. So those are going to be, it's going to be 0, 2 in the A color, and then 0, 0 in the A color. All right, up next we have 1, 0 in the A color. As you can see from here, there's nothing new that we can see here from here, so nothing to add. We're going to look at 0, 2, right? And so this backtrack is going to point, again, since we're on the same floor, we're going to use the arrows. It's going to point here. There's a wall here, so again, we're going to keep that as unreachable. We'll take that out, and so we just added, that was 0, 3, A, and the next one's going to come out is going to be 0, 0. As you can see, did I miss anything? Did I miss any of the states that I added? Okay. So next thing we're going to do is look at 0, 0 again. Nothing in the A, even in the A color now, there's nothing that's new. You cross that out. And then finally, here, let's erase these. And so this was 0, 3 in the A state. So now we're gonna look at 0, 3 in the A state. Okay, now we can go down again, right? And as you see, right, when we go down, we point up, right? If we go down, that means we came from above it. We're gonna point up, so from 0, 3, we're gonna add 1, 3. In the A state. And then again, right, we're just gonna keep going because we're kind of blocked in. And then finally, we're gonna add the B button, but while it's still in the A state, so that's gonna be 2, 3, A, pointing upwards again. All right. From the B state, again, it's a button. So now, once we inspect this state, we see that the color of this button is different than the color we're going in. So we're going to add the corresponding tile in that button's color. So now it's going to be 2, 3, and B. And so now we need to do another, right? Our third dimension of backtracking is going to be that we got to this tile in the B backtrack from same row and column, but in the A color. So we can just put like an A here. Okay? Looking at that, we can travel down again to 3, 3. Our color is now B. It's going to point upwards. And again, right, this is set up pretty nicely. It's just going to ignore everything until we get to the goal. And so we're going to look at this wall. In the B state, it's open space. So again, we're going to point backwards. And so that's going to be 3, 2. And then after that is going to come 3, 1. And then from 3, 1, we're going to get 2, 1 and 3, 0. So it's 2, 1, B, and then 3, 0, B, right? So we had coming from here, pointing down here, and looking at that. So let's take out, so finish with 3, 2. We're now going to look at 3, 1, right? Again, nothing new to add. Looking at our backtracking again, since it has information, that means that it is reachable. So we're not going to add it back again. And then we'll look at 2, 1. From 2, 1, we can add, right? We can add the A button in the B state. So that's going to be 1, 1, B. And then so you might think that we pressed the A button before, right? We pressed the A button before when we got here, but again, this is in a different state. And so what you'll see is that if we weren't about to find the goal, you'd see that when you traverse to this state, you looked at 1, 1B, you would then say, okay, should I add 1, 1A? But we'll see that it already is visited, right? It was visited when we stepped on the A button the first time from the trap floor. And so in that case, right, if you somehow get back to the same position on the A floor, you can assume that whatever you did the first time you got there, you're just going to do it again. And so we're going to ignore that state if it were to come up. But as you see, right, the next thing we take out of our reachable collection is going to be 3, 0, B, and that is the solution. So again, we're going to save this, and then we're going to do backtracking. Right, so again, we'll create our path. Hopefully this isn't too long. And so it starts at 3, 0, B. And then again, we're just going to follow the arrows until we finally get to this starting tile. So we're going to go from 3, 0, B, and then we're going to go to 3, 1, B, then 3, 2, B, right? As you can see, right, even though we looked at these tiles, right, our backtrack information doesn't always flows back to the start. It doesn't really matter that we look at these tiles because they're not on the path that leads to the start. So look at 3, 2, and then 3, 3, and then we'll look at 2, 3, B, right? So that's the A button in the B color, or that's a B button in the B color. And then we're going to look at 2, 3A. That's the B button in the A color. And then we're going to go 1, 3, A, 0, 3, A. And then we're just going to keep going back to the start. 0, 3, and then we're going to 0, 2. All right, and then starting again, right, 0, 1. And then 1, 1, A. That's the A button. And then so now we're gonna go back to 1, 1 in the trap. We're looking here from 1, 1 in the trap. We're gonna go to 0, 1 in the trap, and then finally we're back at the start. 0, 0 trap again. We can keep cross-referencing where we should go by using our state as a way to inspect what a specific item inside the 3D vector, right? So we have a row, column, and then a color, right? That corresponds to each of these axes. And so that gives us, again, a one-to-one relationship between every single piece of backtracking information we could have. So this is our path. Again, this is backwards. So if we wanted to print out list mode, you would have to flip it, right? So again, you use a vector diverse iterator, or you can use a deck and push front. And then for creating the map output mode, again, you can do the same thing. You could, there's multiple ways you can do it. You could kind of take all of this, since you probably stored these as characters, again, to save space, you could just copy the correct map output to all of the spaces, and then walk through and then add the pluses where they need to go, along with the asterisks and the percent signs. Or you could write logic to print this map. Again, it's a little bit more tricky to print this map in the order that you need to essentially copy and paste the path from here onto this map. So I hope that helps you with the 3D backtracking. I want to thank Andrew for filming. And yeah, good luck with the project.